Welcome back to Electricity with Mr. B. In this session we're going to be exploring how to measure electricity. So here we have a simple digital multimeter, or DMM. Now it's called that because it can tell you all sorts of things about an electrical circuit, and we're going to go through a few of them today. So the first thing we're going to explore is voltage. And I've talked about voltage a lot, like a battery, an AA battery having 1.5 volts and a larger batteries having 12 volts. And we can measure that using the digital multimeter. We have a look on this side, we've got V, and then the three dotted lines and the solid line. That tells me that's a voltage for direct current DC, which is what we're interested in today. And we've got lots of options. We've got 600 volts, far too high for what I'm doing. 200 volts, still too high. 20 volts, 2 volts, and 200 millivolts. So millivolts, thousandths of a volt. That's going to be too low for what I'm worried about. So I'm going to switch to 20 volts. So that means the multimeter will read anything up to 20 volts. Anything more than that, it won't break it, but it won't be able to read it. So all we do is we have these two probes here, and they plug in. So at the bottom we have our black one called COM, which goes in the middle, and then the red one can go in either side depending on what we want to do with it. Now we're only interested in basic low level voltage today, so we're going to plug it in on this side. So maximum 600 volts, and that's the multifunction one. The other one, that is for measuring amps, and we'll talk about that a little bit later on. That one in there. So I've set up a very simple circuit. I've got two AA batteries wired in to an LED, which are just placed into the terminals. Now I can use the digital multimeter to find out how many volts that has. Now if my batteries are healthy, it should be about 3 volts. So all I do is I take two probes and we put them onto the terminals of the battery. So at the moment they're both touching there, and it's showing me minus 2.88 volts. That's because I've got the probes in the wrong order. It doesn't do any harm, all I have to do is just swap them over. That's better, my circuit still works, and I've got 2.88 volts. So that's about right for these batteries. They're getting a little bit old, they're still doing the job. Now that feature where it tells you whether it's positive or negative is quite handy if, for example, you've got a circuit where you're not sure which one's which and it really matters. For example, on a solar panel. We've seen solar panels in previous episodes. We've got the wires coming out of the big panel, but they're both black. Normally you think, oh yeah, red cable is the positive and black cable is the negative, like on this one, which has been sensibly wired, but this one hasn't. It's both black wires. Now I could just plug it in and see whether it works, but the trouble with that is if I wire it in the wrong way around, I risk breaking something and it not working. So it's best to use a digital multimeter to check first. So all I've got to do is attach my two probes to the two wires and see whether I get a positive reading or a negative reading. If I get a positive reading and the red, whichever one the red probe is touching, that means it's the positive. So I can check that now. I was having a little trouble there getting the wires to show up on camera, so all I've done is connected the two black cables to some crocodile clips, but it's the same thing. So let's have a little look. We've got one wire connected to a red crocodile clip, we've got that to the probe, and let's see what happens when we attach the black one. Okay, so they're both connected, and we are getting minus 17.03 volts. So that tells me straight away that the wire that I've connected to the red must in fact be the negative. If I swap those over, I will get the correct polarity. And there we go, we're now getting the correct polarity in voltage. So I now know which wire is which. I've actually had this problem before with the wires, which is why I took the trouble, having used the DMM, to give the wires a little label, plus and minus, so I don't have this problem again. We can also use this feature to check how reliable equipment is. So for example, I've set up a simple circuit here where I've got a 9-volt battery that I want to use to light up an LED. Now that LED can't cope with 9 volts, so what I've done instead, rather than get a small battery because it's all the way over there and I can't be bothered wiring that up, so instead I've used a little regulator. All that does is it limits the voltage to around 5 volts. Now these are cheap little bits of equipment, so I want to use my digital multimeter to double check that my voltage is correct. So I've put my probes in here and here. Circuit goes round and it is lighting it up, and I check on my DMM and I'm getting 6.7 volts, a little bit high for what it's doing, so I'm going to retire that little bit of equipment. It's fine for this circuit, but it's not quite right for the purpose that I want, because I want 5 volts. So amps, I've changed the setting on the DMM to amps, and we're looking at 200 M, that's 200 milliamps, because I'm looking at a very small circuit. It's 3 volts and I've got my LED. Now to measure the amps, it's not like measuring volts. I can't just place the probes on and get an immediate reading. I have to interrupt the circuit, I have to break it and complete it using the probe. So I'm going to disconnect the circuit. I'm going to connect one end to the probe. There we go. And if I reconnect the other end, the circuit works. And let's do that again. There we are. I can now get my reading for amps, and I'm getting somewhere around 45 milliamps. 45.2. It's jumping a little bit just because the connection's not that good. So that tells me how many amps I've got. So I've got way less than 1 amp. Now I can put the amp reader or the amp meter to some good use with my solar panels. You saw in a previous episode how you need a solar charge controller to send the correct voltage to the battery. Now this solar charge controller has got a voltmeter in it, which says 12.4 V. But it doesn't have an ammeter. An ammeter reads how many amps it has, and that really tells you how powerful it is. The 12.4 volts doesn't tell me too much. The amps tell me really how much power is behind it and whether it's having a good effect on the battery. So I'm going to interrupt the circuit. I'm borrowing a positive connector for the solar panel. So I put the probe in place where the wire was, and I connect the other probe to the wire that should be going in there to complete the circuit. There we go, we can see it's working because that solar panel symbol's come back on, and more importantly, let's have a look at the amps. Oh dear me, 3.1 milliamps. So this solar panel is producing less amps than that circuit with the LED. That's not good at all. It's actually gone down a tiny bit to 2.2 amps. And the simple reason for that, it's inside. I mentioned last time, it's behind a pane of ultraviolet protective glass. So what happens if we take it outside? Okay, so we've moved everything out into daylight. We've got the solar panel actually facing the sun, wired up to the controller and the battery, and wired in the ammeter. So let's see what it does. Now, I mentioned earlier about the 2 different holes. I actually moved the red probe from here to here and changed the setting to 10 amps because this is going to be more, well, I'm expecting it to be more than 1 amp, and so it simply won't cope connected to that one, so I've got to change it to the other one. And let's connect it up and see what happens. Yep, we're getting sunlight, and at the moment we're getting 0.4 amps, 0.5 amps. The sun's coming out, so it is rapidly going up. 1.12, 1.23, 1.13, 1.14. Now, what happens if I then lift this and move it slightly? 1.28, shift it some more. 1.43, 1.44. Excellent. So by angling that and pointing it more towards the sunlight, I'm getting very nearly 1.5 amps, which doesn't sound that much, and it's not much, but bear in mind, this is a very small solar panel. In actual fact, this solar panel is only rated to be about 1.4 amps, so 1.49 is very good indeed. Now that's why you often see solar panels angled when they're on buildings, so that they get the maximum amount of sunlight, so they can give the most electricity to the battery. So the higher the amps, the faster you'll charge up the battery. Well, hopefully now you know a little bit more about how digital multimeters work, and I'll see you next time. Bye.